Hello and welcome to This Explainer. Today, we're tackling a massive, heavy, and, let's be honest, often terrifying question. When will the Earth end? If you spend any time reading the news or watching sci-fi movies, you've probably felt that creeping sense of looming dread about the future. I mean, we are constantly bombarded with these intense images of zombie outbreaks, rogue asteroid impacts, massive solar flares, or alien invasions. But today, we are going to untangle the end of the world without the Hollywood fear-mongering. We're going to completely replace that anxiety with a wholesome, grounded, and incredibly fascinating scientific understanding of deep time.
Okay, let's dive into this and calm some of that anxiety. We're going to break this massive subject down using a clean, logical, scientific blueprint. First up, defining the real end. Then, the forces reshaping Earth, followed by 3 levels of failure. After that, Earth's habitability thermostat, and finally, humanity's unique vulnerability.
Section 1. Defining the real end. You know, the word end is doing way too much heavy lifting in our everyday conversations, and we really need to unpack it. Seriously, when someone talks about the end of the world, what do they actually mean? I want you to really think about that for a second. Do they mean the physical planet Earth suddenly disappearing into a cloud of cosmic dust? Do they mean all biology and life disappearing? Or do they mean human civilization and our complex infrastructure completely breaking down? Because scientifically speaking, those are absolutely not the same event. In fact, they happen on completely different planetary clocks, separated by millions or even billions of years. Understanding the massive philosophical weight of these different timelines is our very first big step today.
Holding on to this separation is the absolute anchor for this entire explainer. We are essentially looking at 3 totally different parallel stories. First, Earth surviving simply means the planet still exists as a giant spherical rock orbiting the sun. Second, life surviving means biology, in some form, finds a way to persist. And let's be real, even if the surface becomes a completely harsh wasteland, the cockroaches and deep-sea microbes, they'll probably do just fine. Third, humanity surviving means our specific species and our complex, interconnected civilization remain intact. Once you separate these 3 concepts, the rock, the biology, and the society, a lot of that scary apocalyptic language we hear every single day becomes so much clearer and honestly far less intimidating.
To really grasp this, we have to compare the Hollywood myth to scientific reality. In the movies, the end is almost always this cinematic, sudden event, right? Everything vanishes all at once in a massive flash of blinding light. But scientific reality operates on the massive scale of deep time. It's a story of gradual, relentless change. Think of it kind of like sea air wearing down an iron gate. The gate doesn't just poof out of existence overnight. First, the paint fades over a decade. Then, the rust slowly spreads over a century. Then, certain weak points buckle, and eventually the structural integrity fails. For Earth, this rusting process takes millions or even billions of years. The end completely depends on what part of the system you're actually tracking.
Section 2. The forces reshaping Earth. We need to introduce the physical engine that keeps our planet constantly changing.
A planet is absolutely not a static, frozen object. It's a massive, dynamic system in continuous motion. And energy flow is what powers this perpetual change. A world transforms because energy moves through it. On Earth, we have radiant energy coming from the sun up above, warming the surface, driving the weather, and feeding the plants. And deep inside, we have leftover primordial heat from the Earth's very formation, feeding volcanoes and shifting those massive tectonic plates. Think of it exactly like a kitchen stove heating a large pot of water. If the heat is on, the water bubbles, rolls, and circulates. Earth is that pot, actively circulating because its internal heat is always on. And thankfully, that internal heat also generates the magnetic field that protects our atmosphere from being totally stripped away by the solar wind.
But here's the thing. Physics only tells matter how to move. Chemistry tells matter what it can actually become. Elements like carbon, oxygen, and water aren't just passive ingredients sitting in a bowl. They have incredibly strong preferences and reactions. Think of a bustling restaurant kitchen. You can take the exact same basic ingredients, flour, water, and yeast, and make a fluffy, soft loaf of bread, or you can make a dense, crispy pizza dough, entirely depending on the system and how they're combined. Earth's deep future is basically an ongoing, planet-sized chemistry experiment. For example, there wasn't always abundant oxygen in our atmosphere. Early life literally had to synthesize it over eons, fundamentally changing the recipe of the entire sky.
Now, what's really interesting about this is the fascinating concept of feedback. Feedback is exactly why planets can seem completely stable for tens of millions of years and then suddenly shift into a radically new state. Imagine holding a microphone too close to a speaker at a concert. A tiny ambient sound gets picked up, amplified, fed back into the system, and suddenly, bam, you get an unbearable, deafening screech. That is a runaway feedback loop. On Earth, a small warming trend can melt reflective white ice. Less ice means the darker ocean absorbs more sunlight, which causes even more warming, which melts even more ice. Small changes rapidly compound and reshape the entire globe.
Section 3. 3 levels of failure. How do these forces actually lead to different outcomes?
Understanding these powerful forces completely shifts our perspective on what the failure of Earth actually looks like in reality. Think of Earth like a grand old house. A house can be remodeled. It can be stripped entirely down to the bare wooden studs. It can be severely damaged by a storm, or it can simply be abandoned by its tenants. But despite all that, it is still physically a house. Earth can lose its protective atmosphere, its oceans can literally boil away into space, and it can lose its habitability for complex life, meaning the biosphere totally fails. But the physical, rocky planet itself will still stubbornly exist orbiting the sun. Even if real estate values completely plunge to zero, the property itself remains.
But then we reach that final, most sensitive layer of the system, human civilization. For civilization, failure means the collapse of global food systems, the loss of climate stability, and the breakdown of modern infrastructure. But ask yourself this: if our intricate supply chains, our agriculture, and our power grids collapse, does the Earth still exist? Yes. Does basic biology still exist? Absolutely. We can completely lose the delicate infrastructure we rely on every single day, while the planet itself simply shrugs and keeps on spinning through the void.
Section 4. Earth's Habitability Thermostat.
Let's move forward and see how this builds, because you might be wondering, why hasn't it failed yet? Despite all these massive forces of constant change, Earth has 3 incredible stabilizing factors that have kept it broadly usable for life for billions of years. First, the carbon cycle acts like a remarkably slow planetary thermostat. When volcanoes pump way too much carbon dioxide into the air, the world warms, rain increases, and that rain physically washes the carbon right out of the sky, locking it into rocks on the seafloor and cooling things back down. Second, our massive deep oceans absorb and move an enormous amount of heat. They act as a giant thermal buffer against wild extreme temperature swings. And third, life itself. Biology isn't just along for the ride. Forests, plankton, and microbes actively modify the atmosphere and soils to sustain themselves. These 3 mechanisms work beautifully in tandem to prevent Earth's climate from drifting too far into the extremes.
Section 5. Humanity's Unique Vulnerability. Let's look at our place in this deep time system.
When we place ourselves into this immense, deep time system, the story becomes much more urgent. Human civilization is by far the most contingent and vulnerable layer of this entire planetary engine. Why? Because we require a remarkably narrow, highly specific set of conditions to survive and thrive. We need abundant liquid water. We require incredibly stable climate ranges over centuries just to grow our crops. We depend on predictable seasons, and we rely on vast, delicate, interconnected infrastructure. We aren't just basic biology. We are biology plus technology plus global coordination. That combination makes us incredibly powerful as a species, but it also makes us profoundly sensitive to even minor planetary changes.
So, the crucial point is this: Earth surviving is absolutely not the same as Earth remaining habitable. A planet can easily persist as a giant, barren rock in space, while its surface becomes radically, totally different. Our world has survived complete glaciations, massive volcanic epochs, and devastating asteroid impacts. The rock always makes it. But the highly specific, fragile set of environmental conditions that allow our modern civilization to thrive, that is what is actually at stake when planetary systems begin to shift.
I want to leave you with this final, provocative thought. Which end are you actually preparing for? The next time you see a terrifying, doom-laden news headline about the end of the world, you don't need to default to panic. You now have the scientific clarity to step back and ask, what exactly is being threatened here? Is it the massive rock? Is it the fundamental biology? Or is it our fragile human infrastructure? You can now read planetary change like a master mechanic reading a complex engine. Thank you so much for joining me on this explainer, and I hope you keep that incredibly valuable lens of clarity with you.